This video is titled What is Relative Atomic Mass and How Do You Calculate It? So it is a calculation video and you will need a periodic table and your calculator for the second half of the video. We're going to look at the definition of relative atomic mass, so kind of like what you'd see in the textbooks, what it is in terms of looking at the periodic table, and how we then use the periodic table to calculate relative atomic mass, and how we also use what we call isotopic data to calculate it as well. So here, first of all, is just your kind of standard definition. So remember, the periodic table is showing you all of the elements, and each square on the periodic table is talking to you about an atom of that element. Okay, so if you look here at sodium, all of the info here is talking about one atom of sodium. Now, realistically, the mass of that actual atom is so tiny, and the number would be so small that it'd be really difficult to use those in calculations. So what they do is we actually use what we call a relative atomic mass. Okay, and you use your periodic table for these questions. We're going to be looking at this number, the top number in the periodic table on each of the elements. Okay, now a couple of different names that come up. I'll always be referring to it as the relative atomic mass. You sometimes see that shortened to RAM, and other videos that I've seen sometimes talk about and they call it RAM. And then when we're writing it kind of like in calculations and stuff, we'll be looking at it as what we call AR. So in terms of what does the relative atomic mass actually mean, you can also use the relative atomic mass to compare the mass of atoms to one another. So for example, if you look at hydrogen has an AR, or a relative atomic mass, of 1, you could say that carbon has a mass of 12, so therefore it is 12 times heavier than an atom of hydrogen. Okay, or you could say that one atom of magnesium is 24 times heavier than one atom of hydrogen. So you can use the masses and you can compare them to one another as well. So looking at the periodic table, I've taken both of these. These are cut out from the data sheet that you get in your exams. You get periodic tables both at GCSE and at A level without fail. It's a standard thing that you're entitled to, just like you're always allowed to use your calculator as well. So this is what one of the elements will look like, and you've got 4 bits of information: 1, 2, 3, and 4. Okay, and the key is really important. I don't think students use this key enough because they forget it's there, or they're not quite sure what each of the different parts mean. Okay, so the top number, so relative atomic mass, is 1 for hydrogen. So the top piece of information is the relative atomic mass. The next thing down is the atomic symbol. Okay, so the letter or the 2 letters that is being used to represent the element. You've then got the name of the element, so you can see here hydrogen, and then we've got another number, which is the atomic proton number. So of course, again, sometimes students get confused between atomic mass and atomic proton number. I always try and stick to using the bottom number and only calling it the proton number, so dropping that atomic word, so that you have atomic mass at the top, proton number at the bottom. So therefore, if you don't have the word atomic in both of them, it's less likely that you'll get confused. So in terms of this video today, we are focusing on the top number. So if you're looking at your periodic table, you are looking at the top number for all of the elements. So this is a classic example. And you can see that it will simply ask you, or a question could ask you, use your periodic tables, what is the relative atomic mass of, and it could give you a couple of elements or just one element. So all you need to do is literally look at your periodic table, find that element and write down the top number. So if you want to do that along with me, you pause the video now because the answers are about to come up on the screen. So you can see here, list of numbers there. They are the relative atomic masses of those elements. And I've just put here, why is this number a decimal? Why does chlorine have a decimal, whereas all of the other elements, apart from another one, which is copper, why do only 2 elements have a decimal place? whereas all of the others are whole numbers, and it's linked to isotopes. Now, an isotope is kind of like a different form of an element. It's something that's taught to you quite early on in the course, so in like the first couple of chapters of any GCSE course. The standard definition is it's the same number of protons, different number of neutrons. That's what an isotope is. So I'm not going to talk too much about isotopes in terms of what they are and their definition. But what I am going to talk about is how we can use the data of an isotope to calculate the relative atomic mass. So you can see here the first sentence just says the relative atomic mass is not always a whole number. For example, the AR relative atomic mass is of chlorine is 35.5, and it's because when we not that you ever have to worry about this, but when the mass is given for an atom, you actually take into consideration all of its isotopes, okay? So remember, you can have lots of different isotopes of just one element. We take into account all of their masses to get the relative atomic mass of just one of the atoms, okay? And at GCSE, you are expected, let's say for argument's sake, they gave you a list of masses for certain isotopes. You would have to be able to use those to then calculate the relative atomic mass, and you are using this calculation here. It is one that you'll have to memorize, okay? So we're going to be calculating relative atomic mass using the percentage abundance of each isotope and that isotope's mass number divided by 100. So I'm just going to show you what the questions would look like, and I've got the calculation here to help us each time we do an example, okay? So this says naturally occurring bromine is composed of two isotopes, bromine 79. Now, where they put the numbers here and bromine 81, that is the mass number of that isotope, okay? And that's quite common that they show it here, like bromine dash and a number. That is the mass number of that isotope. And actually what I'll do is I'll just add that there. So that number there is the mass number of that isotope. Okay, so naturally occurring bromine is composed of two isotopes, bromine 79, and there is a 50.5% of that isotope, so a percentage abundance of bromine 79 is 50.5 and bromine 81 is 49.5. What is the AR, i.e. the relative atomic mass of naturally occurring bromine? So lots of the time students say to me, oh, why can't I just write down the atomic mass of bromine from the periodic table? You could, but you will actually see that in our answer it's going to be slightly lower than the mass that you see, so therefore you would lose the mark, okay? So if I was going to write this out, the AR, or the relative atomic mass, it's going to be the sum of the two isotopes, okay? So I need the percentage abundance of the isotope. I'm going to do the first one, 50.5 times 79, and remember it's the sum of, so I need to also add in the data from the other isotope. So I've got 81, oh no, sorry, I need to write the percentage first, don't I? Doesn't matter, but if I'm sticking to what I've written in my equation here, I should really. 49.5 times 81 divided by 100, okay? And everything is divided by 100. So in terms of where I got the numbers from, so this 50.5 is from here, and it's the percentage abundance of bromine 79. Remember, the mass number of that isotope is 79, that's why it's here. I've then got 49.5 times bromine 81. Okay, now I believe, I will double check it on my calculator, this should add up to something or a number slightly below 80, which is what you could have got from the periodic table. Again, you can be doing this live on your calculator as well. Yep, so this comes out as 79.99. Okay, that's our final answer. Okay, now if you look in the periodic table, you'll see that bromine has an atomic mass of 80. Okay, so it hasn't asked me to round the answer here, so that's what you'd put down as your answer, 79.99. Yeah, you will see that if we'd rounded it, we would have got 80. The fact that a decimal has come up as your answer, unless they've asked you to round it, you realistically should leave it as it is. So your final answer is 79.99, and the fact that the number has come up just below 80 shows that you shouldn't really just use your periodic table here, because they want you to show your working out, which is all of this. They want you to show all of your working out and show that you can calculate the relative atomic mass using data from isotopes. Okay, final answer here, 79.99. My final example is chlorine. So it says naturally occurring chlorine has two isotopes, chlorine 35, and there is a 75% abundance of it, and chlorine 37, which has a 25% abundance. So again, all we're going to do, is use the equation here in the box, and we're going to plug in the numbers that the question has given us. Okay, so the sum is going to be AR. And it says the sum, so we need the percentage abundance of each isotope. We've got 75% of chlorine 35. We've then got 25% of chlorine 37. You divide that by 100. Okay, so final time where I've got these numbers from, the percentage abundance of each isotope is 75 and 25. The mass numbers is the number that's directly in its name, so 35 and 37. So again, I'm doing these live, so I'm just going to plug this into my calculator, and I believe that this one comes out exactly as the periodic table gives it to you. Okay, divided by 100. Yep, it gives you 35. Okay, 0.5, and that is exactly how chlorine appears in the periodic table. Okay, so yes, you could have just put 35.5 down. If you're lucky, you might get 1 mark for that, but you normally pick up marks for your working out, and that's why it's so important that you don't just use the periodic table to write your answer. Okay, so I'd recommend now maybe rewinding the video, having a go at the 2 examples on your own, pausing it before I've gone through them, but atomic mass is very, very simple. And like you can see that if they aren't asking you to use the isotopic data, you aren't really calculating atomic mass, you're just using the periodic table to give you that information. If they then ask you to use isotopic data, they're going to give a question to you like so, like you can see on the screen now. It's a very, very basic calculation, and you just need to plug in the information that the question gives you, and then you get your answer. So you're never really looking at high marks of these questions, perhaps 1 or 2 marks. Okay, in terms of other videos that you might now want to watch, there's another video on my channel called Relative Formula Mass. What is it? How do you calculate it? Sometimes students get atomic mass and formula mass confused, so it might be a good idea that you watch these 2 videos back to back.